So the technique that we've developed and we've been working on with Florida is using existing structures that are already grouted. We're using what we call the interstitial spaces, so the little space between the individual wires of the strand. So if you look at the end of here, if this was a strand, you're going to have a little gap between each of the individual wires. You can come and take a look up here. You have a little pinhole, kind of a gap between each of the wires. We're using that as a longitudinal capillary along the length of the duct. And we're introducing material either into the end of the tendon or from a central location. But for the demonstration, we're going to do it from the end. And we're going to push it along those interstitial space and out the other end of the end of the duct through that little pinhole, right? In the field, when you do this, you're normally going to use the grouting caps, and you're going to clean the anchorage, and you're going to pump all of the strands at once. Okay. For the purpose of the demonstration, what we've done is we put individual injection ports over top of the end of individual strands. Yeah, in the field for the jobs that we've done with Florida, we've actually used the existing vented grout caps. We've removed the grout cap, removed the grout from inside there to expose the anchorage, put the grout cap back on, and we've used exactly the same grouting port as was used for the original grouting for the impregnation. And we're grouting all of the tendons at once. For the purpose of the demo, we're going to connect onto one strand on the far end of the tendon. We're going to pump it through. And probably what we're going to see is it come through a strand in a similar location first, and then we'll cap them off as they're coming out. And as we cap them off, even though we're going to pump from one location at the other end, we'll see that it'll slowly move radially across the section of the duct. I can see it's a very, very low viscosity material. It has two functions that it's basically been developed to do. One is to make soak into the surrounding grout and to make that grout impermeable, to reduce the permeability of that grout surrounding the strands. And in places where there's no grout, like in the voids, that material will form a film on the surface of any exposed steel that will be essentially coating for a barrier for corrosion. And so, yeah, so basically it's coming in along the, like you saw, it came out the first strand here first, and then it's moving laterally. Oh, we got one that's not plugged, where it came out. Okay. And we've got a little leak at the end down here, but you can see it's a very low viscosity material. It's now coming out these holes here are 1/4 inch diameter holes that were just drilled at random through the duct into the grout inside, and they were just drilled until we just touched the outside of the strand. So you can.
Does this material harden over time?
It will form a film on the surface of the steel as it basically hardens. It doesn't harden like an epoxy. It has more of a pliable nature to it. And you can see it's starting to come out of this last one here. Yeah. So anyway, this is a very, very small sample of the real size thing, but I mean it's the real diameter, but just a short length.